the June 2015 question on centre of mass. So you've got this shape here, a uniform. Got rectangle, triangle, and the circle is removed. BC equals CD, which makes this nice isosceles triangle. Find the centre of mass from AE and AB. Now the first thing you should always do with centre of mass questions is draw yourself a table. So you've got shape, area, weight, centre of mass from AE, and centre of mass from AB. Okay, so 3 different shapes we've got. We've got the rectangle, isosceles triangle, and a circle. So area rectangle, length times width, 160. So weight is 160 mg. Triangle, base times height divided by 2 gives you 45, so 45 mg. Circle, pi r squared, so you get pi. Now the radius is circle. If this one is 2, and this is 2, that gives us 4. We're going all the way down is 10, so left over is 6, so each of these are 3. So the radius is 3. Which gives us 28.26 mg. You can leave this in terms of pi if you want. Okay, now we need to add on the total. So remember, the circle is removed. So we need to add these two parts and take away the circle, which is going to give us 176.74. Now then, centre of mass. So we're going from AE, so we're going from here, and we're going across. Sorry about the lights again. Okay, so we're going from AE and we're going across there. So for the rectangle, it's right in the middle. So you go from AE, go across to the middle will be 8. Halfway. Going the triangle from AE, we have to go 16 before we even get to the triangle. And if I isosceles triangle, it is a third of the way up. So we got 16 going across, and it's a third of the height, which would be 3. So that gives us 19. For the circle, we've got 4 to get to the circle and 3 to get in the middle. So that's 7. Okay. Next one then, centre mass from AB. Going up the rectangle halfway is 5. At the triangle halfway would be 5. And the circle is 2 and 3, that's also 5. So now we know the centre mass from AB is just going to be 5. Okay. Now to get the total for each of these, we can draw ourselves another quick little sketch. Okay. And we're going to say the centre mass is somewhere there. And we want to find X across and Y going up. Because going as if you're going across the X-axis and up the Y-axis. Right, pretty much got this table, don't really need the question, okay? You're just going to say equate moments about two systems from AE to start. So, equating, this is our second system. I'm going to start with this one. From AE is X. Remember, moment is force times distance. Or in this case, yeah, distance will be X, and the force will be 176.74 mg. Okay, and that's going to equal all of the other ones times by the weights. Okay, so we've got 8 times 160 mg, 19 times 45 mg. Now be careful, we're taking away the circles, that's why it's a minus, and we've got 7 times 28.26 mg. We've got mg in every part, so they can cancel out, and then we get 176.7x. This is going to give us that, this will give us that, and that will give us that. Okay, calculating this, we end up with, bring this over and divide, so x is 10.96. Now for y, we already know all the y's came out to be 5. And just using the fact that it's symmetrical, we know it's going to end up being 5. You could go about and do this whole thing from AB and you still get the same answer, okay? So we can just say that y is going to be 5. So that means you've got across 10.96 add up 5 there.